Welcome viewers. In this video we will see the double field revolving theory available in the single phase induction motor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic double field revolving theory in single phase induction motor. As the name single phase induction motor, we are not using single phase winding. While using single phase winding, the net flux produced is zero. So this theory explains how the net flux is zero in a single phase. Because in single phase, during positive off cycle, the flux is produced. During negative off cycle, the flux is produced is a negative. So both are got cancelled. The net flux is zero. Flux produced by positive off cycle is cancelled by flux produced by negative off cycle. So this theory explains how it is zero. For that reason, we are using two phases in a single phase induction motor, starting winding and running winding. In order to make the net flux, in order to create the net flux, we are using two windings, starting and running winding. After motor starts running, the starting winding is disconnected, only the running winding will be available. The principle of operation of induction motor, the separate video is available. So this double field revolving theory explains while using only one winding how the net flux is zero. Step by step it will explain. This theory make use of the idea that an alternating uniaxial quantity can be represented by two oppositely rotating vectors of half magnitude. So the alternating uniaxial quantity we are going to deal, that is divided into two oppositely rotating vectors. Right, the net flux is divided into two halves, both are oppositely rotating. Okay. Then we'll go to the next detail. Accordingly, an alternating sinusoidal flux can be represented by two revolving flux. Right, so it is divided into two, that is represented by the two revolving flux, each equal to the half value of the alternating flux and each rotating synchronously in opposite direction. Right, so we have two fluxes of equal magnitude, what is rotating in opposite direction. We know that synchronous speed n is equal to 120 f by p. F is frequency, p is the number of volts. Now we refer the diagram A. So this is the net flux, maximum value of flux pi m, that is now divided into two equal parts, pi m by 2 A, another pi m by 2 B. Right, the total flux is divided into two halves with A and B are rotating in opposite direction. A rotates this direction, B rotate that direction. Both are in opposite direction. As shown in diagram, let the alternating flux have a maximum value of pi m. Its component flux is A and B will each of equal to pi m by 2, revolving in anti-clockwise direction and clockwise direction respectively. Right, so the maximum flux is pi m, that is divided into two equal parts, pi m by 2 A and B. Right, this B rotates in clockwise direction, A rotates in anti-clockwise direction. So step by step we see how the net flux is zero while rotating in this direction. So this diagram A now we refer. Now we'll go to the next diagram B. Refer this diagram B. So after some time, when the A and B would have rotating through the angle plus theta and minus theta as shown in the diagram. We know that A is rotating in anti-clockwise direction, B is rotating in clockwise direction. After some time, it is in this position with an angle theta plus theta and minus theta. So this vector sum of these two is the resultant, pi m cos pi. By using the parallelogram theorem, we can find the resultant vector, that is the vector sum of A and B. Right, so initially at this position A and B, after some time it is rotating clockwise direction as well as anti-clockwise direction. At the time we have got this diagram B. it is rotating, we are assuming that rotating at an angle of theta, plus theta and minus theta. This is the resultant flux. Now we'll see the what is the resultant flux, the expression. We'll see the expression. So the resultant flux by using parallelogram theorem, it is 2 into pi m by 2 cos 2 theta by 2. So 2 got cancelled, here also 2 got cancelled, it is pi m cos pi. So the resultant flux will be pi m cos theta. Now it is in theta. Now we'll refer the diagram C. So after some time, initially A available here, rotating in anti-clockwise direction at an angle theta, we referred B. Now it is available in this position at y-axis. The A is available at y-axis. Similarly, B rotating in clockwise direction, initially at this position in diagram B at an angle of minus theta, now available in this vertical manner, y. Right? So A available at the top, B available at the bottom. After a quadrature cycle means it is approximately, it is a 90 degree. Flux A and B will be oppositely directed as shown in the diagram C. So the resultant flux would be 0. Right? So A positive, B negative means both are got cancelled, net flux will be 0. Right? So initially at this position, in diagram B at an angle theta, in diagram C it is oppositely, it is both are in opposite direction. A available at the top, B available at the bottom. So the net flux is 0. Now we'll see another two diagram. This is keep on rotating. This flux is keep on rotating. So after some time, the A start rotate from the top of this position. It will go to up to at this position A. Similarly, B initially B available at the bottom, still keep on rotating in clockwise direction and available at this position. That is exactly opposite to that of the diagram A. In diagram A available this side, now diagram in D available that side. Now it is minus pi m. So this side, while referring diagram A, it is plus pi m. While after rotating to diagram D, it is minus pi m. Still these two are rotating continuously. So the now A available here, B available here. B will still rotating in clockwise direction, A rotating in anti-clockwise direction. So A will come down and B will go to upward. Right? Now A available bottom, B available at the top. So here also both are in opposite direction. The net flux is 0. Now we'll refer this diagram. This diagram C, A available at the top, B available at the bottom. In diagram E, A available bottom, B available at the top. So still it is 0. So the diagram A, the flux is pi m. We'll go to diagram D, plus is minus pi m. So got cancelled. In diagram C, A available top, B available bottom, net flux 0. In diagram E, B available top, A available bottom, still both are opposite, the net flux is 0. So step by step we are analyzing. In each cases, one flux produced in one position is cancelled by the other position. So that is our aim. How the resultant flux is 0 in a single phase winding. Now refer the another diagram, flux diagram. This is the angle theta. So initially 0, 90 degree, 180, 270, again 360 or 0 degree. So the phi diagram we referred. So flux, y-axis is flux. When it is at 0 degree, diagram A, what we got? Flux is pi m, maximum value. So while rotating, that is A is rotating in anti-clockwise, B is rotating in clockwise direction, what happened? The flux keep on decreases and become 0. Right? So both are in opposite, that is 0. That is the diagram where C we referred. Diagram C, it is A at the top, B at the bottom. So the net flux is 0. Still it keep on rotating. A rotating anti-clockwise, B rotating clockwise direction. So it will goes to the negative maximum pi m, maximum value, but in the negative side, minus pi m, what we discussed in the diagram D. Still it keep on rotating here. So the flux is increasing in negative direction and become again 0. That refers the diagram E. Right? Again the same process repeats. From 270 to 360, the flux is increasing and again reaches maximum value. This is the original position. right? So at 0 degree the flux is maximum pi m. While rotating clockwise and anti-clockwise direction, both are opposite side. The net flux is 0. Still it keep on rotating clockwise and anti-clockwise direction. It will goes to negative minus pi m. Again while rotating, again it's both are opposite. Both are placing in opposite direction. The net flux is 0. Right? So the flux produced this side is cancelled by positive flux produced is cancelled by negative flux. The net flux is 0. After half a cycle, flux A and B will have a resultant flux of minus 2 into pi m by 2, that is minus pi m. After a quadrature of a cycle, again the resultant flux is 0 as shown in the diagram E, and so on. Right? So this refers the diagram A. This 0 both are diagonally opposite diagram C. This will diagram D, negative, exactly opposite of diagram A. This will refer the diagram E. Again it is in both are in opposite, become 0. Right. Now we'll go to the remaining value. If we plot the values of resultant flux against theta between the limit 0 and theta 0 to theta 360 degree, the curve similar to the diagram. So this diagram will got. If you draw the curve between angle theta and flux, we'll got this resultant flux. Now we'll go for further analysis. So that's why an alternating flux can be looked upon a composite of two revolving flux, each of half value and revolving synchronously in opposite direction. So we are consider two revolving flux, both are in opposite direction. Initially maximum value pi m, then 0 value, then maximum value in negative direction minus pi m, again 0. So that represented by 4 diagrams. So it may be noted that if the slip of the rotor is S with respect to the forward rotating flux, that is one which rotates the same direction as a rotor, right? So if you refer, there are two fluxes A and B. One that is a rotate in the as a direction of rotor, we can represent that S means, then the slip with respect to the backward rotating flux is 2 minus S, right? So the one flux, if you consider as a rotation of the rotor is S mean, another flux will be, the slip will be 2 minus S. So we have S and 2 minus X, the corresponding slips of the two revolving fluxes. One is S, another one is 2S. Each of the two component fluxes while revolving around the stator cuts the rotor and induces the EMF. This production is one torque, right? So these two components will produce the EMF and thereby torque. Now we'll see the torque curve. The graph shows the torque. So this is the slip S is available here. This is the torque, y-axis torque, x-axis slip is 0, this one 2.0. So what we referred, S 2 minus S. In this clockwise direction, this is clockwise direction, so the flux produced is positive. So at that time it reaches the maximum value and reduces. In anti-clockwise direction, the flux is negative. The same what we produced in the clockwise, same, but it is in negative. So that due to that we have forward flux and this forward and backward torque, forward torque and backward torque. So this is the result. This is the torque produced. Right. So this is the resultant torque. This is the torque produced by forward torque. This is backward torque. Combination of these two, sum of these two is the resultant flux. So in the clockwise direction we got positive value, in the anti-clockwise direction we got negative value. So we can go for further analysis. This is refer S, this side refer 2 minus S. See the now power developed by the rotor Pg equal to 1 minus S by S into I2 square into R2. So general formula. If N is the rotor n is the rotor RPS, then the rotor torque is given by Tg equal to 1 divided by 2 pi n 1 minus s divided by s I2 square into R2. From the power we can write the torque equation, right? This rotating in RPS, we consider RPS, right? So now we have the two torque S and 2S. Based on that we can go for the further analysis. We know that n equal to ns into 1 minus s. Brought this 1 minus n in the denominator, so that n divided by 1 minus s equal to ns. Now write it in reciprocal. 1 minus s by n equal to 1 divided by ns. Right. So 1 minus s divided by n can be replaced by 1 divided by ns. Now we'll consider this equation. Now we'll rewrite this equation. 1 divided by 2 pi. The n is written here. 1 minus s by n. This 1 minus s and n is written here. This 1 by s is written separately. I2 square R2. Right. Now the equation is rearranged. It is in the form 1 minus s by n. So this 1 minus s by n, this can be replaced by 1 by ns. Right. So now what we have, 1 divided by 2 pi s. This s is available here. N 1 divided by ns I2 square R2. Right. Now we'll go for further simplification. 1 divided by 2 pi ns. This ns is written here. This s is combined with this. I2 square R2 divided by s. So finally what we have, this can be written as constant. 1 divided by 2 pi ns. Constant. I2 square R2 divided by s. Right. So this is the normal torque developed by the rotor. But what we have, forward torque and reverse torque. Forward and backward torques are available. So from this equation we can easily identify the value of forward and backward torque. So this is a normal equation. Now we'll consider forward and backward torque. TF, forward torque equal to K into I2 square R2 divided by S, as it is. In case of backward torque, minus K, because negative. I2 square R2 divided by 2 minus S. We already referred. The rotor rotating in the same direction, the slip is S. Opposite direction, the slip is 2 minus S. So this is the same direction, this is opposite direction. S, 2 minus S. So otherwise it can be written as TF equal to I2 square R2 divided by S. That's a synchronous watt, another form. Right. Similarly here, minus I2 square R2 divided by 2 minus S, synchronous watts. This is normal formula, this is in synchronous watts. So the total torque is TF plus TP, forward torque plus backward torque. So from the diagram, the graph what we shown, both torques are resultant torque for the slip between 0 and plus 2. At standstill, S equal to 0 and 2 minus S equal to 1. What we discussed in the diagram is available between 0 to plus 2. The torque is, the slip is what we represented 0 up to plus 2. So at the standstill, S equal to 1, that we know that. Similarly, 2 minus S equal to 1. Now we'll see how this resultant flux is 0 in here, how it is concluded. Hence, forward torque TF and backward torque TB are numerically equal, but being oppositely directed produce the no resultant torque. From the graph we are easily identify that both are same magnitude, but it is opposite. One is positive and another one is negative, so the resultant torque is 0. That explains why there is no starting torque in a single phase induction motor. Right, so the aim of this topic is double field revolving theory is, while using single phase, why the resultant torque is 0. So why we are easily identified from the graph. So in the diagram we referred 5 diagrams. Initially pi m, then 0, then minus pi m, again 0. This keep on changing. So the resultant torque is 0, resultant flux. Similarly in the diagram 2 we refer the torque. There also resultant torque is positive, negative, clockwise positive, anti-clockwise negative. So the resultant is 0. From that we conclude no starting torque produced in the single phase induction motor. However, if the rotor is started somewhere say in the clockwise direction, the clockwise torque starts increasing and the same time the anti-clockwise torque starts decreasing. So if we start the motor by using any other way, what happened? The clockwise direction the torque increases, anti-clockwise direction the torque will decreases. Hence there is a certain amount of net torque in the clockwise direction accelerate the motor to full load. So still if we start rotate by any other way, any other manner, that's why we are using starting winding. So that the motor is started by the starting winding, thereafter the clockwise direction definitely there will be some torque is produced. The torque will accelerate the motor to the full speed. So that motor will retain the motor will accelerate. That will guide the motor to rotate in the full speed. So if it is single phase used in the single phase induction motor, the net torque produced, net flux produced is 0. If it is started by any other manner, either capacitor start or induction start or any using the starting winding, once the motor start rotates, what we concluded, in clockwise direction the torque increases gradually, anti-clockwise direction torque decreases gradually. So after starts rotating, definitely the torque available in the clockwise direction accelerate the motor to attain the full load speed. So that is the important conclusion from this topic, double field revolving theory. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.